All right, Honors Chem, today we're going to clarify a little bit about ions. So I'm going to do a different row. We already did like lithium and nitrogen and some other ones, but I'm going to pick a different row from the third principal energy level. So the third principal energy level is right here. Notice at the top here, it says 1A. Everybody in this family has one electron in the outside energy level. So one valence electron, and we're dealing with the third principal energy level. So first is sodium. Sodium has 11 protons, and when he is an atom, he has 11 electrons. Now, remember, the first principal energy level with hydrogen and helium only holds 2 electrons. And then the second principal energy level, which is lithium through neon, holds 8 electrons. So we're going to fill those up. And then that last principal energy level, so here's the first 10, has 1 electron. That's the valence electron. That's the single electron in the outside energy level. When sodium becomes an ion, he could either lose that 1 or gain 7 more. It's easier to lose 1. He's a metal. Metals tend to lose electrons. When he loses 1 electron, he doesn't have 11 anymore. This time he has 10. So if you add up 10 pluses and 11 pluses and 10 minuses, you end up with 1 extra plus. So the charge on sodium and everybody else in family 1 is +1. Remember, we just write plus. Let's go to magnesium now. Magnesium has 12 protons in the nucleus. And when he's an atom of magnesium, he also has 12 electrons. Let's place his electrons in the electron shells. 2 for that first principal energy level, that's all it holds. 8 in the second principal energy level, and then you'll see this Roman numeral 2 above magnesium's family, which is the alkali earth metals. He has 2 electrons in the outside energy level. I've placed total of 12 electrons. When magnesium is going to form an ion, he will give away both of those electrons in the outside energy level. It's easier than gaining 6. So when he gives those 2 away, he's also going to have 10. Notice, just like sodium, he wants to be like neon with 10 electrons. Everybody wants to be like a noble gas. So if you have 12 pluses and 10 minuses, you have a charge of +2. This is how we write the ion for magnesium is 2+. Let's go over, because remember, this only works for the guys who have A next to their family number. The Roman numeral followed by A tells us the amount of electrons in the outside energy level or the amount of valence electrons. Next is aluminum. Aluminum has 13 positive protons, and as an atom, he has 13 negative electrons. So with 3 in the outside energy level and 13 total, 2 in the first, 1, 2, 3, 4, 5, 6, 7, 8 in the second, and then 1, 2, 3 in that last side energy level. So he could either lose 3 or gain 5. He's still a metal, so he's actually going to lose these 3. It's easier than gaining 5. When he loses those 3 valence electrons, he'll have 10 electrons, again like neon. If you add 13 pluses and 10 minuses, you get a charge of +3. So aluminum as an ion is written like this with a charge of +3. Here's our ions. Now, look at carbon family here. Silicon would be the one in the carbon family that we would worry about. He has 4 valence electrons, so he could either lose 4 or gain 4. And the reality is sometimes he loses 4 and sometimes he gains 4. So he could either be +4 or -4. But we're going to leave him alone for now. We're going to go stick with the ones that we're going to use most often. Let's go to the 5th family here, the nitrogen family. And in the 3rd principal energy level, we would be dealing with phosphorus. Phosphorus has 15 positive protons. And when he's an atom, he has 15 negative electrons too. Let's fill in all 15. 2 in the 1st energy level, 8 in the 2nd, and then 1, 2, 3, 4, 5 in the outside energy level. This time, he would have to lose 5, or he could gain 3. What phosphorus likes to do, because he's a nonmetal, is he likes to gain 3 electrons. When he gains 3 electrons, he now has 18 electrons, just like argon. And 15 pluses and 18 minuses give us a charge of -3. So that's the ion that phosphorus would have. Let's go to the oxygen family. Chalcogens are called sometimes. And we're dealing with the 3rd principal energy level, so that would be sulfur. Sulfur has 16 protons, positive protons in the nucleus. And when he's an atom, he has 16 electrons. Let's place all 16 of those electrons. 1, 2, 8 in the 2nd. And then he has 1, 2, 3, 4, 5, 6. Now, he would have to lose 6, or he could just gain 2. And he's going to gain those 2. He is a nonmetal, so he likes to gain, and that would give him 18 minus electrons, just like argon. Plus 16 minus 18 gives you a -2 charge on the ion. So sulfur will have an ion charge of -2 like that. Next one is chlorine. Chlorine has 17 protons in the nucleus. You're going to start seeing a pattern here, aren't you? So 1, 2, 3 electron shells. 1, 2, then 8 in the 2nd one. And then 7 in that last one. So he could either lose all 7 or he could gain 1. And that's what he'll do. When he gains 1, he has 18, just like argon, and a charge of -1. Just like pluses, if we have a -1, we just usually write minus. Last guy, let's do argon. Argon has 8 electrons in the outside energy level, just like he wants. He doesn't have to want to be like a noble gas. He is a noble gas. So he has 18 protons, and his first 3 energy levels are full. So there's no room for extras. He doesn't want to give any away, and he doesn't have to, and he won't. So we'll put the 8 in the outside energy level. We'll acknowledge that he doesn't have any room for any extras. He doesn't have any extras he wants to give away. He will not do any of that. With 18 protons and 18 neutrons, he is going to stay as an atom electrically neutral and will not form an ion. That's why he's a noble gas. So there is a quick summary of ions.